Good morning, everyone. My name is Bo Sang, and I come from Ningxia University. Today, I'd like to share a brief review about additive manufacturing in medical application. I'm going to present this brief review from the following 4 sections. First of all, its introduction. 3D printing technology was born in 1990s and has been extensively used in a variety of fields such as industry, pharmacy, architecture, clothes, training, and so forth. This paper research on this technology for medical purpose concentrates on the following 4 important areas. First, bioactive permanent prosthesis implants and scaffolds. Second, pathological organ models. Third, directly printing tissues and organs. Fourth, drug delivery. Although such applications remain a long way from widespread clinical applications, as several key technology and fundamental scientific issues that are yet to be overcome. Notable scientific advancements and applications have been achieved in this area. 3D printing technology is known to be an additive manufacturing technique used for the manufacture of products in consecutive layer series. 3D printing allows significant advancements in medical equipment, implant, material, and cell printing. The processes of 3D medical models by additive manufacturing are that. First of all, creating a 3D CAD model of the individual patient by the use of CT, MRI, 3D scanner, and so forth. Then, converting digital imaging and communications into STL format. Next, printing of patient-specific implants via use AM technology, and then post-processing of implants. Next, testing of implants. Finally, implementation of the implants in the patient bodies. Figure 1 shows the process of 3D printing technologies to create an anthropomorphic thorax phantom. A vast range of materials are used to build 3D models for the medical industry. Apart from the common typical material like metal, PLA, and carbon fiber, I'd like to talk about some emerging interesting material like tissue and cell. This material can be used to improve the whole organ and the damaged tissue, to create desired cell type, and to be used for organs for transplantation, human tissue repair products. Now, let's see the 4 main medical applications. First of all, it is bioactive permanent prosthesis implants and scaffolds. Permanent implants can replace human body parts and play a parallel function in the rest of the patient's life. Wonder combined CT imaging and 3D printing technology to achieve customized titanium plane in order to repair the patient's skill defect. Figure 2 shows a case that a customized cranial titanium implant and a titanium implant for an Australia patient. Next, it is pathologic organs models to assist pre-operative planning and surgical treatment analysis. Faraki conducted a cardiac magnetic resonance imaging of a woman with tricuspid valve hypoplasia and printed a 3D model on this basis. As Figure 3 illustrated, they could quickly and plainly view the severely dilated and deformed right ventricular from the outside of 3D printed model, and the tricuspid value leaflet could be seen to be relocated from the inside to the right ventricular outflow, which was useful in preparing the positioning of inflow and outflow sleeves for ventricular assistance systems. Then, it is directly printed tissues and organs. Laranda suggested a system for rehabilitation of ovarian mice use gelatin hydrogel printed artificial bell microporous scaffolding. As Figure 4 shown, bell prosthetic ovary created using 3D printed gelatin microporous scaffolds restores variant function in mice. This scaffold was used to grow follicles and to further produce the artificial biological ovaries that could be prepared and inserted in the missing sections of the mice ovaries. Last, it is a versatile platform for drug delivery. As Figure 5 shown, channeled systems have been investigated to optimize the release of medications from immediate release formulations. Similarly, caplets containing internal holes, referred to as caplets, are developed to facilitate separation of fast-release tablets and to prevent the need for disintegrants. In the end, we draw a conclusion. Additive manufacturing (AM) technology is at a flourishing level, and its uses in adjuvant surgery, permanent prostheses, replacements, and rehabilitation medical equipment are becoming more and more mature. Applying 3D printing to adjuvant therapy can help physicians optimize surgery preparation, promote diagnostic and preoperative instruction, develop doctor-patient contact, and assist in teaching research to increase the success rate of surgery. The individualized implant is more consistent with initial anatomical form, which increases patient satisfaction and aesthetics following surgery, and it is useful for post-operative rehabilitation. Medical use of direct printing of tissues and organs may resolve the problems of loss of organ donor and immune rejection. Thanks for your listening. If you have any question, I'd like to answer that now.